Welcome to the Manual Integration Toolbar. So as comments up front, let me say that manual integration is often a very time-consuming, repetitive operation on mass spec data as well as 2D data. And yes, there are situations that require manual integration when you don't have the chromatographic separation. Many compounds in a run. You could get bunching, peaks on a sloping baseline that the integrator isn't able to identify, partially resolved isobaric compounds, the Achilles heel of mass spec, isobaric compounds, and then you've got the whole array of humpograms and blobograms, all to be dealt with by manual integration. The manual integration toolbar. So why? Well, first, faster. Single click of the common operations that you would do, and to be shown later, the multi-select operating on multiple chromatograms at the same time. So the manual integration toolset was really meant to speed up these common operations. It was not intended as automation. It's just an assistant. It speeds up actions. The responsibility for manual integration lies with the analyst, and manual integration inspection is still part of that. So quickly, there's really two locations where the manual integration toolbar appears. First, there's batch at a glance, which allows you to manually integrate a single compound at a time, and then there's the presentation of compounds at a glance. Now, compounds at a glance amplifies the power of the manual integration toolbar. So let me repeat. In compounds at a glance, the manual integration toolbar enables multi-select. So thus, you can operate on multiple chromatograms in one click. So if you spend too much time manually integrating, you should certainly consider its applicability. Thanks for your attention. Well, first you need to expose the manual integration toolbar, and you can see there's two categories here. First, the manual integration, and then a set that's involving retention time manual integration, and these can be added to the toolbar as you see here. So the first step is, let's start manual integration. So if you click on the main toolbar and start up manual integration, then you will see these enabled and you're off and ready to go. Let's go through these one at a time. So first, clear manual integration. That will set the integration back to what came from the integrator. And next we've got zero peak. So zero peak assigns zero area, which typically calculates out to a zero final concentration. Next we've got some that are peak manipulators. So merge right peak. That merges an alternative peak found to the right into the existing primary peak. And that can be used to create composite peaks like compound groups by adding and then adding again to the peaks that appear to the right to get an aggregate amount. And the mirror image of that is merge left peak, doing the same thing to the left side. All right, here we've got split peak and pick left. This finds a low point between the peaks and attempts to assign only the area to the left as the primary peak, basically chopping off part of the right side of the current peak. And the mirror image to that is the split peak and pick right. Please note that none of these algorithms is perfect. The last two in the manual integration toolbar are snap baseline, which is quite useful to draw underneath and then snap up to meet the chromatogram. And the last one is the drop baseline, which will drop down the side which is highest to meet the side that is the lowest, and you'll get a flat baseline there. Let's take a look at the retention time manual integration part of the toolbar, and that's comprised of two choices. The first is apply ISTD retention times to the target. Now, this is seriously useful when employing heavy ISTDs, like in peptide Quant, that share the same physical separation properties. So if you can assume the ISTD shares the same retention time start and retention time end, you can now assign from the ISTD to the target this retention time window and pick up any signal that shows up for that target, regardless of the shape. Similarly, apply target retention times to the qualifier. So in this case, if you can assume your integrated target shares the same retention time start, retention time end as your qualifier, you can assign these target retention times to the qualifier and then pick up any signal found in that retention time window, regardless of its shape.